In this video, we're going to be doing related rates problems. Related rates problems have two or more rates that are changing simultaneously, and our rates are always going to be with respect to time. So we have a couple examples of just can we write down a rate. So this first one, it says the length is increasing by 2 inches per second. So I would write this, you choose a letter. So I'm going to choose L for length. I'm going to say dl dt equals 2, and then we want to put our units 2 inches per second. Another rate, letter B, the volume of a sphere is decreasing 7 centimeters cubed per minute. So I'm going to use V for volume, dV dt. Because my volume is decreasing, I'm going to make my rate negative. We need to keep that in mind when we do these problems. So I'm going to say -7, and then my units are centimeters cubed per minute. Notice all of your rates are with respect to time. Seconds, minutes, hours, years, something like that. So let's do some full examples. Example 1 says a rectangle's length is increasing by 4 meters per minute and its width is decreasing by 2 meters per minute. Find how fast the area is changing when its length is 12 meters and its width is 4 meters. So first thing is I always recommend drawing a picture. So we have a rectangle and we're talking about the length and we're talking about the width. I also always put down what we know. So I know the length is increasing 4 meters per minute. So I'm going to say dl dt is going to be positive 4 meters per minute. We know the width is decreasing 2 meters per minute. So I'm going to say dw dt. It's decreasing, so -2 meters per minute. Now it's switching to asking what they want. So now I'm going to say we want, find how fast the area is changing. So now I want dA dt when the length is 12 meters and the width is 4 meters. So I'm going to say I want dA dt when length is 12 meters and width is 4 meters. So I always recommend doing this at the beginning. Draw a picture, write down what you know, write down what you want. Once you do that, now look at what you have. I'm talking about area, I'm talking about length, and I'm talking about width. What equation do you know that relates all of those together? I know that area of a rectangle is length times width. Once you have your equation, you are going to take the derivative with respect to time on both sides of that equation. Now, it's super important here, we don't want to plug any of this in until after we've taken our derivative. So we always do that after the derivative. So let's do it. You're going to be using implicit differentiation. If you would like to see a video on that, I will have it linked in the description, but we are doing implicit differentiation here. So derivative of A, we're going to say is dA dt equals, on the right side of the equal sign, I'm going to use a product rule. So I'm going to start by taking the derivative of L, that's dL dt, times W, plus, now I'm going to leave the L, take the derivative of W, that's dW dt. Once you've taken your derivative, now you can plug stuff in. So I'm solving for dA dt. dL dt is 4. W, where when W is 4, my width. Plus, plug in your length. Plug in your dW dt. Notice we simplify, and that gives us our dA dt. So I have 16 minus 24, which is -8. Don't forget your units. We're talking about an area, so that's going to be meters squared per minute. And that is this first example. We've got a few more. Example 2 says the short side of a right triangle is increasing 4 feet per minute and the long side is decreasing 2 feet per minute. So we're talking about a right triangle. We know we're talking about a short side and a long side. So I'm going to say S and L. The short side, ds dt, is increasing 4 feet per minute, and the long side is decreasing, so dl dt, decreasing 2 feet per minute. Then it says at the moment the short side is 9 feet and the long side is 12 feet. How fast is the hypotenuse changing? I'm going to make the hypotenuse h. So we want dh dt when s equals 9 feet, L equals 12 feet. So I am talking about the three sides of a right triangle. So we're going to ask ourselves, what equation do I know that includes all three of the sides of the right triangle? That's going to be your Pythagorean theorem. So a squared plus b squared equals c squared. But in this case, we have different letters. So s squared plus l squared equals h squared. Same thing as the previous one. Our next step is to take the derivative with respect to t on both sides. And we're not going to plug anything in until after we take that derivative. So I'm going to start with s squared. That's going to be 2s ds dt. We need to chain rule the s. Derivative of s is our ds dt. Next, derivative of l squared. That's going to be 2l dl dt equals 2h dh dt. To make it simpler, I'm going to divide each term by 2. You definitely don't have to do that to solve the problem, just makes it a little bit simpler. Once we've done that, I'm going to plug in. So my s is 9, ds dt is 4, L is 12, dl dt is -2. Notice we don't know h. So now I'm going to go back, and I'm going to go back to my want, because I want dh dt in this moment when s is 9 and L is 12. So in the moment, I can figure out what h equals. S is 9, L is 12. Notice that this is a 3, 4, 5 right triangle, just multiplied by 3. So 5 times 3 is 15, so h is 15. That's a Pythagorean triple. If you can't do that, that's fine. You're just going to do Pythagorean theorem. And then solve for h, you'll get h is 15. So either way you want to do it, but we do get that h is 15 in that moment. Keep solving. We get dh dt equals 36 minus 24 is 12 over 15, which simplifies to 4 over 5 feet per minute. That is how fast the hypotenuse is changing. It's increasing 4/5 feet per every minute. We also want to know how fast the area is changing. So I'm going to steal our no, because that's all the same. And most of our want is the same. Okay, so I want to know how fast the area is changing. So I'm going to change this to be dA dt. And now I'm talking about area and then the two sides of the right triangle. So I'm going to use area of a triangle. So area is 1/2 base times height, but now I have s and L. So 1/2 s times L is going to be my area. I'm going to take my derivative on both sides with respect to t. We get dA dt equals, I need to do product rule on the right side. So I have 1/2 derivative of s is ds dt. And then I'm going to leave the s, take the derivative of L, we get dl dt. Plug in what we know and what we want. I'm solving for dA dt. I have 1/2 ds dt is 4. L is 12. Plus 1/2 times 9. dl dt is -2. Let's see, I get 2 times 12 is 24. My 2's cancel, so I get -9. So this is going to be 15. My units, it's area, so feet squared per minute. Okay, so there's an example with right triangles. I want to do one more in this video with cylinders. I am going to do a second video with more difficult problems, so look out for that. I will have it linked in the description. But this one says a right circular cylinder has a height and a radius that are changing. If the radius is growing 4 feet per minute and the height is decreasing 3 feet per minute, so let's start with that. So I'm talking about the radius of the cylinder and the height. So I'm going to use R and H. I'm going to say we know the radius, dr dt, is growing 4 feet per minute. Height, dh dt, is decreasing 3 feet per minute. Find the rate of change of the volume of the cylinder. So I want dv dt, if v is for volume, when the height is 8 feet and the radius is 10 feet. All right, so it sounds like we need our volume of a cylinder formula. The volume of a cylinder equals the area of the base of the cylinder times the height. So pi r squared h is your volume of a cylinder formula. Let's take the derivative on both sides with respect to t. We get dv dt equals, I'm going to take the derivative of the r squared first, so 2 pi r dr dt, we had to chain rule the r, times h, plus pi r squared, take the derivative of h, we get dh dt. Once we've taken our derivative, we can plug in. I'm solving for dv dt. 2 pi, my r is 10, dr dt is 4, h is 8, plus pi r squared, that's going to be 10 squared, dh dt is negative 3. Simplify, let's see, I get 8 times 8, which is 64, so 640 pi minus 300 pi. This is going to be dv dt. That's going to be 340 pi. Volume, so feet cubed per minute. So my volume is increasing 340 pi feet cubed per minute. We have the same scenario, but now it wants the rate of change of the surface area of the cylinder. So I'm going to steal this. Okay, and then instead of volume, we want surface area. So I'm just going to make it an S. Keep in mind for surface area, we need a formula. I'm going to say S equals, it's kind of like the wrapping of the cylinder. So I'm going to have the two bases. And then if I unwrap the middle part of a cylinder, it's actually going to be a rectangle. So I'm going to have the two areas of the circle, 2 pi r squared, plus my area of my rectangle. This part of the rectangle is the circumference of the circle. So I'm going to say 2 pi r. You could say pi d, but we are in terms of r. So I'm going to say 2 pi r. And h is going to be this height. So imagine you're unwrapping this cylinder. So plus 2 pi r h. To make my derivative a little bit nicer, I'm going to factor out a 2 pi. You don't have to do that. I just feel like it makes it nicer. Let's take the derivative with respect to t on both sides. So I'm going to get ds dt equals, I have my 2 pi. Derivative of r squared is 2r. Chain rule the r, so times dr dt. Plus, we need to do a product rule. So derivative of r is dr dt times h. Plus, leave the r. Derivative of h is dh dt. Once we take the derivative, then we can plug stuff in. I'm solving for ds dt. I have 2 pi. 2 times r, my r is 10. dr dt is 4 plus 4. H is 8. R is 10. dh dt is -3. The rest is simplifying. So I get 2 pi again. This is, let's see, 80 plus 32 minus 30. So this is 2 pi times, this is going to be 2, so 82. And we get 164 pi. So this is ds dt. Surface area is an area, so we're going to say feet squared per minute. Okay, so this was a cylinder example. So these were a few examples of related rates questions. Check out my second video for some more examples. Thank you for watching this video.